Hey everybody, and welcome to one-to-one functions. So in this video, we're going to examine what are one-to-one functions, and we're also going to look at, okay, well, once we figured out what they are, we're going to figure out, okay, well, how to tell if a function is one-to-one, and also wrapped up in this video, we're going to see, okay, well, why do we care in what these one-to-one functions are, and what are they used for? So, but first, a little story. So, suppose we have Juan, and suppose Juan's house is here. So here's Juan. Juan's at his house. Hi, Juan. And one day, Juan gets hungry, and Juan needs to go to get food. And let's suppose food is here. Food. Now, Juan would really like to get from his house to food, so he follows the streets and follows the traffic laws, and he goes right, then he goes right, then he goes down, then he goes right, then he goes down, then he goes right. All while going in this direction. And then Juan is really happy. Yay, I got food, I'm full, I found my way. So Juan figured out how to get from house to food. And all of these were two-way streets. So for Juan to get back home, because suppose Juan has the memory of a goldfish and also can't read maps and doesn't have Google Maps or a phone or anything, and Juan's only thing that he can do is come back the exact way he came. He literally can't do anything else. So Juan, to go back to his house, he says, okay, let me retrace my steps. So I will go left, then I will go up, then I will go left, then I will go up, then I will go left, then I will go left, and then I will be back at my house. And then Juan has successfully gone from food back to his house. This makes Juan very, very happy. Yay! Yay, there we go. So we would always like to be able to go somewhere and come back. So what's an example of maybe when we can't do that? Well, Juan's house is here. So suppose Juan is hungry again. However, suppose Juan lives in a different type of city, like maybe San Francisco, where there's a lot of one-way streets. So Juan would still like to go from his house, and he would still like to get food, and he would like to get back again. So from Juan to get to his house to get food, he goes down, and then he goes to the right. However, this street that he just took was a one-way. So he is able to still get from his house, and he is still able to get food, and he's still happy about that. However, when Juan goes to turn around to try to get back to his house, here's Juan, he's now going to try to go back. Oh no, I can't go this way now because it was a one-way street. Juan can't go back the exact way he came, and that's all Juan knows how to do. So Juan cannot go from his food back to his house, and so Juan is stuck. Oh no. So function-wise, if and Juan is basically a number moving through functions. So Juan was able to get from one place to another. However, he couldn't get back because a one-way street, you can only go one way down the one-way street. So Juan is stuck. So we would really always like Juan to be able to get where he's going and back again in the exact same way. Okay, well, how could we manage that? And now we're going to switch over to function-wise. Well, we're going to introduce something called one-to-one functions. And what one-to-one functions basically do is they say, okay, well, if you're a one-to-one function, then you always have a path from one place to another, and we will always ensure that you can always get back again. Okay? So that's what we're going to explore today. We're going to explore these one-to-one functions. And one-to-one functions are, there's an exact path to get where you're going, and then there's an exact path back, and it's the same exact path. So let's look a little more at maybe why we care. So why do we care about one-to-one functions? One-to-one functions. Why do we care if there's a way back? Okay, why do we care that we've mapped something from one place to another and there's an exact way to get back? Well, because inverses. In order to have an inverse is, so a function going one way is going from Juan's house to food. In order to get back, the path from food back to Juan's house, this would be the inverse way. And the only way that an inverse could exist, or that we could get Juan from his food back to his house, is that we had an exact way. In other words, there wasn't any one-way streets, there wasn't any blockages. We could get exactly back. Every turn that we did had an exact opposite turn to it that was legal for us to do. So we care about one-to-one functions. Because of one-to-one functions, we can have inverses. So not all functions can have inverses on their entire domain. One-to-one functions can have inverses. So that is why we care about one-to-ones, at least right now. So what is a one-to-one function exactly? So math-wise, every element in the range corresponds to exactly one element in the domain. So it's 1, 2, 1. Every element corresponds to exactly one element. Just like here, 1 goes to 3, and 3 could go back to 1. 2 goes to 4, and 4 could go back to 2. 3 goes to 5, and 5 could go back to 3. This is basically Juan going from his house to food, and there's an exact path back. 1 goes to 3, 3 goes to 1. That's the exact path. Okay. Unlike this example over here, this is a square root function. Square root of 4 could either go to -2 or +2. There's too many ways to get back, and 1 goes to 2 here and not 1 to 1. Okay, many to 1, so this is the square function. We have 2 inputs going to the same output. 2 and -2 go to 4, and 3 and -3 go to 9. So there's too many that go to 1. Or we have the many to many, so that is not 1 to 1, that is not 1 to 1. For instance, 6 hours could be mapped to 360 minutes, or it could be mapped to 0.25 days. 1 minute could be mapped to 60 seconds, and all of these can kind of map to and from each other. It's a whole mess, and that's not 1 to 1. This guy here is what we're looking for. Why? Because again, there's an exact one way to get from one number to the other number, and there's only one way to get from that number back to the number that it started with. That's the requirements for inverses. Okay. Otherwise, there's too many places for Juan to get lost. Here, remember, Juan's simple. Juan can only go forward and backwards. Juan can't come up with any other path. So that's what a one-to-one function is. How can we tell if we have a one-to-one function? Well, the test is a graphical test. It needs to pass the vertical and the horizontal line test. So if we look at just a regular linear, notice a linear will pass the vertical line test. We will only hit the function exactly once at any vertical line. And now it also passes the horizontal line test. It only hits the function exactly once. So it passes vertical and horizontal line test. That thing is a function. On the contrary, our good old parabola, these guys pass the vertical line test, but they fail the horizontal line test because it passes through those 2 points. So no, that is not a one-to-one function. The other way to tell is if f of a equals f of b, then that would imply a equals b. And if not, then it's not a one-to-one. So basically plug in a to your function, plug in b to your function. So an example, if we have f of x equals 3x plus 2, plug in a to your function, plug in b to your function, set them equal to each other. Oops, that's not the function, that's the function. Set them equal to each other, That's also not the function because it's 3a plus 2 equals 3b plus 2. Okay, subtract 2, so we have 3a equals 3b, divide by 3, divide by 3, a equals b. Check. This guy is 1-to-1 because we solved it out and we got exactly a equals b. Let's do some examples. Some more examples. So are these guys 1-to-1? Let's go with 3 and 4 first because those are a little easier. So if you have a graph, does it pass the horizontal and vertical line test? This guy passes the vertical line test, yes. It also passes the horizontal line test. It always only hits exactly once. So 3, yes it does. Number 4, nope, it looks like this will fail the horizontal line test because it hits 3 times there, so no, that guy is not 1-to-1. So graphs are really easy. Vertical line test, horizontal line test, if it fails either of those, no, it's not a 1-to-1 function. For number 1, so if you have the equation, plug in A, plug in A, plug in B, set them equal to each other, solve out. Okay, well, how do we get rid of that negative 3/5? Hey, let's multiply by the reciprocal on both sides. Negative 5/3. Remember, reciprocal, just turn it over. Anything multiplied by its reciprocal equals 1, so those both equal 1, which means that we are going to end up with, indeed, a equals b. Hey, yay! That's a 1-to-1 function. Great. Alright, what about f of x equals 2x squared? How do we check? Plug in A, plug in B, set them equal to each other. Plug in A, plug in B, set them equal, and let's see. Alright, divide by 2 on both sides. Remember, whatever you do, you have to do to both sides. So we get a squared equals b squared. Oh no, quadratic. How do we solve quadratics? Get everything over to one side, set it equal to 0. Get everything over to one side, set it equal to 0. Hey, a squared minus b squared factors because I remember how to factor a difference of squares, which I know you guys all do too. Okay, set each little piece equal to 0. Subtract b from both sides. Oh no, a equals negative b. That's not what I want. Over here, let's see, add a equals b. So, I check out over here, but I don't check out over here. So what that means is that if I restricted my domain, in other words, if I only wanted to enact this function on a particular set of numbers, I would indeed get a 1-to-1 function. But overall, on the whole domain, I do not, because when I solve this out, one of my solutions was a is equal to negative b, and that's not going to work. So no, on the whole domain, this is not indeed a 1-to-1 function. So in conclusion, so why do we care about 1-to-1 functions? So in order to find an inverse, first we need to know the function is 1-to-1 on the particular domain. So that's important. 1-to-1 means each element of the range goes exactly to one element of the domain. How do we figure out if something is 1-to-1 or not? We use the horizontal and vertical line test if it's from a graph. And if you have the equation, you could always graph with graphing software, or set f of a equal f of b, and determine if a equals b to test if the function is 1-to-1. So in other words, plug in a, plug in b, set them equal, solve. Does a equal b? Yes, you're 1-to-1. Does a not equal b? No, you're not 1-to-1. So I hope this was enlightening. Please, as always, ask questions as you need, and I'll see you guys in the next video.